Officially welcome. Thank you for being here and joining us for Agentic AI workshop this evening. My name is Diana Honish-Haig, and I get to serve as the Director of Retention for our online degree programs at the University of San Diego. So I get to work and support all of our Masters of Applied Artificial Intelligence and Masters of Applied Data Science students. So thank you for being here tonight. I'm excited to welcome our guest facilitator. So this workshop is going to be facilitated by Dr. Abu Desai, and he is the passionate founder and CEO of Ready Tensor. It's a seasoned AI industry leader. He is admired for his strategic vision, hands-on approach, and an unwavering commitment to making AI accessible to everyone. So please join me in welcoming him.
Thank you, Diana. Hello, everyone. As Diana said, my name is Abu Desai. I go by Abu, make it easy for everyone. And I'm really happy to be here. Thank you for inviting me. So I'm going to talk today about agentic AI. This is now becoming a topic that you're going to hear quite a bit going forward. You will hear the phrase, the future is agentic. And I truly believe that is the reality. I do think the future of work is going to involve AI agents, and not necessarily to replace humans, but as a complement to what we do. And those who learn to use agentic AI in their work, they're going to have their productivity really accelerated, and you could very easily become a 2x, 3x, 5x more productive person with the use of these technologies. We have 3 workshops scheduled this fall for you, and today is the first of its kind. I do want to bring up that there is a code repository that we will be using as part of this workshop. So if any of you wish to follow along with the code examples, I recommend that you clone the repo and just go very quickly through some of the setup stuff you might see in the README. I will cover that when I get to the beginning of the coding exercises. But at the very least, if you're planning to code along, then get the repo. And then as we go through some of the notebook exercises, you can be set up for it. This is workshop 1 of 3, and they're going to grow in complexity as we progress through the workshops. Today, I would call more the introductory or foundational work, although even what we covered today, the technologies, techniques we covered today, are used in, I would say, 90% of the agentic AI projects you will see in industry. Some of the most common applications like chatbots, customer service agents are actually based on the technologies that we'll cover today. Let's cover what we have planned for today. We will start with some basic LLM interactions. LLM stands for large language models. And what we'll do is we're going to do all the work today through our notebook implementation. We'll do some text generation. We're also going to get images created by prompting the program. And then we'll also do some audio synthesis. You will see a pretty short but impressive example for that. The next thing we'll cover is embeddings and similarities. The key part of workshop 1, really the hardest part of workshop 1 is what we call RAG implementations, or RAG stands for RAG, retrieval-augmented generation. And a key part of that is document embeddings. That's what we'll cover. And then retrieval involves similarity. If these terms don't make sense, they should by the end of this workshop. Once we cover these basic elements that go into the RAG implementations, retrieval-augmented generation, part 3 of this workshop will involve going through the code implementation. That's basically our agenda for today: basic LLM interactions, some basics of embeddings and similarity, and then a RAG system. All right, so the 3 key technologies or libraries, packages we're going to use today. Let me just talk very quickly about this. We're going to use a package from OpenAI directly. It's called OpenAI SDK. It's a Python package, and we're going to use it to make LLM calls. Okay, so that's one key technology we'll use today. Next, for vector embeddings, we'll use a tool called ChromaDB. This is open source. It's free to use and a very intuitive, easy to use package. If you don't know what vector DBs are, we'll get into that in this workshop. That's the second technology we'll use. Finally, we will be using this open source package called Gradio. It comes from Hugging Face, and it's wonderful. If you're building UI using LLMs, you're using building applications, and you want to share it with the global community, with future employers, collaborators, I really highly recommend you check it out. Again, it's very easy to use. In fact, shockingly easy to use. When you will see that with a few lines of code, you can build nice chat applications, and they look pretty clean and nice out of the box. You don't really need to make much cleaning or beautification when you're using Gradio. Okay. The 3 technologies: OpenAI SDK, ChromaDB for database, the vector DB, and then finally Gradio for the front-end presentation of these applications we are building. So I will get into some introductory slides, but I mentioned it would be good for you to get started with the setup. And these instructions are also in the GitHub repository that we are going to use. This is the URL. So I would recommend, again, if you're following along with the code, use it. You're going to need to create a .env file. We are going to be making calls to OpenAI using their SDK. And for that, you're going to need an API key. Now, there is no free OpenAI API key. You have to put some money into it, okay? So I'm going to get started with the main content. Again, I mentioned clone the repo, create a .env file in the root of your repo, meaning like in the basic folder. The file should be called exactly .env, nothing before the dot. There's an example file there called .env.example. You can just rename that and then put the key in there. Replace the OpenAI API key placeholder value there, okay? Then once you have that, create your virtual environment, install the dependencies. There's a requirements file in there. You would need to make sure that all the requirements are installed. It should take you less than a minute to do that. All right, just while I go through some introductory slides, just make sure you're set up, okay? Okay, we'll get started. Basic question, what is agentic AI? Agentic AI are basically software systems that have the capability to reason, plan, act, and they do so autonomously. That kind of functionality is implemented by the designer of the system. And the way they work is they're given a goal, a task to achieve, and they have freedom, in a way, control freedom to achieve that task given certain capabilities. That involves the use of some reasoning techniques, which is a bit of a misleading term because there is really no consciousness to this system. So I don't want you to think that these systems are really thinking, but they simulate that behavior that you can feel like this is reasoning behavior, like how humans would reason about the task. And then with the use of tools and then observing what results they see, they can then chart their path until they get to a state where they feel like they're done. Whether it's success or failure, it depends on how the system has been defined to act, but you give that kind of autonomy to these systems. And you can imagine how such a system can be extremely powerful. That's part of these agentic systems. How they differ from traditional software is basically what I would say the main part is the autonomy, where you're giving that kind of freedom of solving a problem to the system. That's a high-level description about agentic systems. So when we talk about agentic systems, I really think in terms of 3 levels, and you will see the similar kind of categorization in other literature. So at the very basic level, some even argue that lowest level is not even agentic in the true sense of the word, but we're going to start with what are called LLM workflows. LLM workflows are very much like traditional software applications where you define the flow like a graph, right? You're defining first do this, then do that. There might be even conditional if-then logic or even loops like for loops, while loops, and so on, but it's pretty traditional. And even I would say traditional machine learning AI applications fall in that level, okay? That's workflows. And when we really start getting into agentic systems is when we start using what are called agents. And agents are these cells of LLMs where you give them certain capabilities, including use of tools. You give some memory, or these days, the more fashionable term is context engineering. And then you also provide them the ability to decide what to do next. Okay, so those are agents, and you can have a single agent system most of the time. A lot of the applications can be solved using single agents. But when it starts to get into multiple agents, the complexity gets quite hard because at this point, it almost becomes like a system architect problem. How do you define the roles of different agents? Who does what? Where are the handoffs? What is the clear delineation of responsibilities between different agents? What tools are made available to each of the agents, and the different architectures that you can put these agents in. In the second workshop, you're going to talk about these agentic designs, patterns. That's not the topic of today's call. We're going to stay focused on LLM workflows for today, and you will see how even that can be extremely powerful. In fact, the most well-done LLM workflows are so well done that as an end user, you can't really tell the difference if there are agents behind the scene or not. They feel like there must be some agents working behind the scenes. You can achieve quite a bit with LLM workflows. So let's see some examples. At this point, I'm hoping you've opened up Jupyter Notebooks if you do plan to follow along with the coding exercises. And you have what is titled Part 1, Basic LLM. That's the Jupyter Notebook we'll take a look at. So we're going to start with basic text completion. And I intentionally called it singleton. Let me zoom in so you should be able to read this. So singleton as in you're going to send some prompt to the LLM and it's going to respond to you. But the next time you send another prompt to it, it has no memory. It's basically singleton. So we'll get into multi-turn conversations later. So here is an example of that. One thing you should get exposed to and just have it register in your mind is this kind of list structure of messages. And within that, this dictionary structure where you're defining a role and a content, okay? In the LLM sense, when you're making these calls, the roles can be the system, right, which is the AI assistant, the human, which is you sending a message to the system. It could also be system prompt. So that's more like the initial instructions you're giving to the system. And then it can also be a tool, which is hard to see why a role can be a tool, but we won't cover that today. But when LLMs are using tools, they come back with a response saying, here's the tool you should use. And then when you call the tool, the role would be the tool used. Okay, so that's the structure is there's always a role and then there's a content. Now, this specific format can be different for different providers. Okay, if you use LangChain as your agentic framework, it's going to be different. If you use the Claude SDK, it might look different, but these two keys will always be there, the role and the content. Okay, so we are basically defining a prompt here, and you can play around with this, write a friendly 2-sentence definition of retrieval-augmented generation. You can play around with this. I'm sure every one of you has used ChatGPT or some of the other chatbots. But yeah, you give it the prompt and then sending it to the OpenAI client. And then we are just saying basically chat.completions. Again, the way it looks, don't worry if it looks Pollyannian. You're usually going to copy paste this kind of code in your applications. So we make that, we get a response, and then you're extracting the response content and you're going to print it out. Okay. All right. So just going to run this cell and you're going to get a response soon. This is our prompt. And this is the response we got from the LLM. Now you can change the model if you want. I think we defined it somewhere up here. Default model, yeah, ChatGPT 4o mini. You can change that to be a less expensive model, more expensive if you want. But at the end of it, you get a response and you can use that. One cool trick is the streaming response, right? So right now what happened is you got the entire response and it popped up on the screen. What if you wanted it to stream that, meaning it appears like it's writing it as you go, right? That's what it appears like in ChatGPT console. So let's make it write some short story about a robot who discovers emotions. Let's see how it looks. I'm going to run this. Yeah, here it is, streaming the output. This is very useful when you're building user interface for your chat applications. It gives you a more natural feel as well. Also, to be clear, this is how generative models operate anyways. If you understand how transformers work, you will know that they are producing next word at a time. And that's how they generate text. So it's really coming out this way. And it helps also to present it like that. So you don't have to wait for the entire text to appear. All right. Again, as I mentioned, I won't explain all the code because it's a really boilerplate code. If you go to OpenAI, the SDK documentation, you will see these examples. And so just copy pasting them and modifying them as per your needs is what you're going to be doing most of the time. Okay. We've done a couple of examples, text generation, streaming text generation. Let's do one for image generation. And you will see most of the structure is the same, right? You have an OpenAI client, which we define above. Then instead of chat, we are doing images and then generate. And we are giving it a prompt. You can define the size and the quality and the model you want to use. So let's see, we have a flat image of a helpful robot. There's quite a bit of art to even writing these prompts, especially for image generation. I'm not an artist by any means, but you can give some pretty fancy artistic styles and instructions here and come up with beautiful looking images. So this is the extent of my creativity. I'm going to run this and we're going to see what we get. This image generation is the most time consuming part. It might take 10 seconds, 15 seconds, depending on the model. So here you see I have what did I say? A flat image of a helpful robot librarian fetching a book title rag from a bookshelf. Teal shade because that's our company color. All right, so you get this. Okay, it wasn't terrible. This model DALL-E 3 is not that great. It's hit and miss. And by the way, you get a different image every time. So you'll get a different one when you run this yourself. But you can try multiple times and you can see what you like. This is based on the prompt. You can still change the style. You can make it different artistic styles if you want. So that's about images. Let's do an audio generation one. Now we're going to give it some static text. But the real beauty of this would be if we are producing LLM generated text and making it say that. In fact, that's an exercise I would really like you to do after this workshop. That's part of the exercises. You can scroll all the way down to the bottom of this. All right, so let's run this real quick. All it's going to do is say this. I hope you can hear this, by the way, when you hear the AI agent speaking. So let's run this cell.
Hello, welcome to the Agentic AI workshop. Let's build some amazing AI applications together.
Pretty cool, eh? By the way, there's different styles. And also we are using a particular model. OpenAI does have its own text-to-audio model, which is what we are using, but there are other companies who have amazing audio generators. In fact, the way of the future is going to be like, instead of me teaching this, it's probably a automatically generated video in a workshop that will present to you, and you will love that a lot better than what a human teacher can explain right now. But that's a little further away, maybe 20, 30 years down the line. But you can see how it's very natural sounding, right? In fact, you can choose the accents, you can choose male, female, other voices, and there's amazing technology here in terms of being able to generate audio as well. Okay, let's move on quickly. I want to get into Gradio, and here, what I'm going to do is put up a very quick interface. You see this, we are using literally one line of Gradio, and all it needs is a function that takes in a message and returns the response. Okay, then you have these other kind of parameters that you pass to it. Let's take a look at this. You can actually do it within inline in Jupyter, but I'm going to open it up in a separate tab. And you can see here, hello. And you see the AI responded, hello, how can I assist you? My name is Abu. Nice to meet you, Abu. How can I assist you today? One line of code, and you have a pretty decent looking interface here, right? And you have these examples which were defined there. And let's try this. Let's get a joke. I know I don't have too much time, but what is this? Okay, I should have. Why don't skeletons fight each other? They don't have the guts. Okay, I don't know if I like that one. Let's do one more. Okay, why did the scarecrow win an award? Because he was outstanding in his bit. So you can build pretty cool looking and useful applications. This is just a toy example for you. And let me do the last one here, which is multi-turn conversation. Actually, let me do one thing. If you remember, I said, my name is Abu. Let's ask, what's my name? I should have made the windows longer, but you can see, I'm sorry, I don't have access to personal information. And this is because this was a single turn chatbot. It really doesn't have any history maintained into it. Okay. So for that, all you need is a little bit more code to maintain the history. This is really what happens underneath the hood when you're talking to ChatGPT or Claude is all this conversation that we are having, it's getting appended in a conversation history. And every time you ask a new thing or prompt, all of that history plus the latest prompt is going to the LLM, and then it has all the history and it returns the response. Now, of course, this can get really long, and in real world agentic systems, you have to manage that context so that you don't go beyond a certain thing called context window. But still, at the most basic level, that is what is happening. All right. So let's run this real quick. I'm going to open this up real quick. And the only thing I will do is just to prove that it does have history. So my name is Abu. Okay, what's my name? Your name is Abu. How can I help you? So as you can see now, it does have the history. And in this case, it's all in memory, but you can persist it. You can save it to disk. And next time the same user comes back, you can load up that history and maintain the conversation, which is what happens with a lot of these agentic systems, the customer support systems. You want to load some of this history so people don't have to repeat some of the information. All right, we've done part one. Let's quickly go to the second part, which is the rack system. One key issue you will know about agentic systems is that they have general knowledge, right? They have knowledge of what's out there in the real world on the internet. But let's take an example. Let's say you're working for a company and you want to build a chatbot for your employees. And it's specifically to ask questions about your company's policies, maybe your HR policies, your employee related information, PTO policy, or things of that nature, right? Of course, that is not out there in the public domain. Companies aren't going to put their HR policies out there. And so how would these systems answer questions? For that, what you have to do is make those knowledge documents available to the chatbot. When a question is asked, you have to make sure that you somehow find the right document, the right information, and you present that to the chatbot as context. You say, here's relevant context. The user is asking this, If you find the information in that context, answer it. If you don't find it, usually you tell the LLM to say, I don't have the information. Okay. So that is when you're trying to build in some more customized knowledge into the LLM's responses. That's why we are using RAG systems. A retrieval-augmented generation is, retrieval is that part, you're retrieving some information from your own knowledge base, and you augment the generation of LLMs using that retrieved knowledge, okay? Now, the key part here is how do you retrieve relevant documents, right? What is relevant in this case? Any company could have literally hundreds, sometimes even 1,000 documents, right? So if someone asks a question about some company policy or some other information, how do you find the right document? You're not going to fit all 1,000 documents in the context. You have to extract something more relevant. And that's what we talk about here in terms of embeddings and then similarities, okay? At a very high level, embeddings are nothing but taking the text and converting those into numbers. Typically, they are like vector numbers, right? So mathematical representation. And what you do is every time you need to retrieve some information specific to a query, you go into the knowledge documents and you find the vectors, the mathematical representations that look the most similar to your query. So imagine like you have 3 documents here. One has, and documents typically are much longer, but let's just say they have single sentences. So first one says Amazon rainforest covers much of South Africa. The next one is this. The third one is this, right? Paris is a very beautiful city. So let's say a user asks a question saying, tell me something about Paris. What is going to happen is that question, tell me something about Paris, gets converted into a numerical representation. And then we find from the documents, the vectors that have the most similarity to it, right? So if, for example, we were trying to find between these 3 vectors, what are the 2 most similar ones? You can see like this vector and this vector are nearest and they're away from this other one, right? If you had something about a recipe for making pepperoni pizza, it's going to show up very different place in this vector representation, right? It's not going to be anywhere close to this. That's what we do is do the vector representations, and then we find a metric that tells us how close these vectors are to each other, all right? So embeddings are vector mathematical representations, and quite often they're very high dimensional. I'm showing a 2-dimensional one here just so you get the idea. The real ones are actually quite complex, okay? Let's say similarity matrix, right? There's many of them. I really recommend you read through them. But you have like cosine similarity, Euclidean distance similarity, and then cosine distance. Distance is really the opposite of similarity. If something is distant, it's less similar. So it's kind of opposite of each other. But there's other metrics as well, Manhattan distance and other ones. There's a lot of them. You can come up with your own metric as well. So that is basically the core idea. Let me quickly go to the second part here of the exercise. So to convert text into embeddings, there are many models available out there, really good ones. There's a lot of really good choices. We stayed in the OpenAI ecosystem here, but really there is no particular reason to just pick that in terms of their effectiveness. There's other equally good embedding models out there. So when I say what is an embedding model, remember I said you turn the text into numerical representation. That's what an embedding model does. You give it some text and it comes back with some numbers. And you don't have to know what the numbers mean. It's just a vector representation of it. And so they're using an OpenAI model. There's some really good open source models on Hugging Face. In fact, our ready tensor implementations of agentic systems, we've used Hugging Face predominantly. And then we have these distance metrics here, cosine, similarity, distance. You can create your own one, as I mentioned. To run through some of this real quick, I'm just running the cells. I created a helper function here just so you can see the results. What I've done here is just for examples, I created 5 documents on different topics: deep learning, forecasting, model deployment, feature engineering, and so on. And so imagine these are our documents, right? These could be thousands of them, and each document could be 10,000 words. It could be pretty lengthy documents too. Again, for sake of this workshop, we kept it simple. I'm going to use cosine similarity as a metric. I'm doing a basic example here. Let's do what's the best way to put my trained model into production. Let's say that's my query, right? Now, really, none of the documents explain that, but we're going to find the one that is closest to it in terms of being able to answer that question. So I'm going to just run this. And you see right here, this was again our query. What's the best way to put my trained model into production? And of the 5 documents, I just label them. You can see the model deployment one has the highest similarity. We are tracking similarity here. And then you have these other documents which have less of similarity with them. Okay. In RAG systems, what you typically do is you have a certain K, meaning like number of results you want to pick from. Usually the K could be something like 3. In our case, really, there's only one good response, but I'm just saying in most real world applications, there's a ton of documents and these documents are big as well. So you could get multiple hits. So you provide all of that context, maybe the top 3 matching documents, send it to the LLM. Let's move through the last example here. Really, at this point, you have all the tools necessary to even build the chatbot, because in the first example, all we were doing is giving a prompt to the LLM. In the second example, the one we just saw, we found documents which are most similar to a query. And so if you want to build a RAG system, all you're doing is taking your prompt, appending these documents inside or injecting them inside. So it's one big text. And your prompt would say, here's a question. Here's some reference documents you can use to answer the question. So that is really all there is to it in terms of the basics of RAG systems. Retrieve relevant documents, and then use that retrieved context to generate better answers. Again, retrieval generation, right? Retrieval-augmented generation. That's what we are doing here. Let's run the last example. This has the most, I would say, complex code, but again, this is boilerplate code. If you go to ChromaDB documentation, Chroma is the vector DB we are using. That is basically going to give you all the examples of the code snippets we are showing here. And you just copy paste them and put them together into a system. Okay. One missing piece here is what's a vector DB. So when we ran the second example, we kept the vectors in our memory. We had 5 documents, we kept them in memory. But you're not going to do that in a real world system. You have lots of documents and you don't keep them in memory. Okay. What you do is you take those vector representations and the documents and you store them in a database called a vector database. This is really not much different than your SQL database or a NoSQL database, which is just a very specific type of database. And it's called vector DB because you're storing vectors in them. So later on, when you're doing retrieval, you find the numbers which are the most closest to your query, and then you retrieve that document. So that's what we are using in terms of vector DBs. We are using a tool called ChromaDB. There's a lot of really good ones out there. Some free, some not free, some really good for enterprise applications, some good for student projects, some in memory, and others you can use them by saving the things to disk, right, as a regular stored database. When we talk about vector DBs, so now we have 2 parts to them. So one is at the ingestion stage. So because you're not doing this every time you're pulling up a RAG chatbot, you're vectorizing the documents offline one time. If you have new documents, you can do more embeddings. You can update the embeddings, but it's done offline. Okay. That's called the ingestion stage. And there's some code here to do that. Okay. You have embedding and then you have ingest documents. And at the end of it, what we do is we save it in a DB. And then come retrieval time, you're using this in your LLM chatbot, you're loading up the DB and you're doing the retrieval. And that's the retrieval part here. You're giving it a query. And this is the K I was referring to, is it's returning the 3 most matched documents for the query. And that's what we are returning to the chatbot. Here are some reference documents. I'll come back to that. But when you're building the prompt to send to the LLM, as I mentioned, it's pretty simple, right? You have a question and you have a context, right? The question is coming from the user and the context is coming from the retrieval. The documents we retrieve, pass it on to LLM, let it respond based on that, okay? And that's what is happening in here. You're constructing the prompt based on the user query and you're getting retrieved documents, which you see here. You're building the context based on that, and then you send it out to the client. All right, let's run this. I'm gonna show quick examples of this. Let's see. Okay, I'm just gonna call the cells. All right, so I have a system, I have the UI. All right, so I also have some basic examples put here. Let's say this is a HR support bot. If employees have questions about the HR policies of the company and you want to get information from these documents, then you build a chatbot, let's say, for that, right? So here's the examples, but you can type it or you can just pick one of these. I'm going to pick one of these just for speed here. So how many PTO days do I get? And here's the answer. This is metadata. I'm just using it to show you what was retrieved, but you can ignore that part. It's more like the metadata just for validation later on. This is the real answer. Full-time employees accrue 15 days of PTO. Where did that come from? I'm going to show that real quick. Let's see the documents. Record work, pay time, right? So really what it did is it found that information from here, right? It's employees accrue 15 days of PTO, increasing to 20 days after 3 years and so on. And that is what it's presented here. Now, again, this seems like it's pretty trivial, but this, when it's done on a large scale, thousands of documents, hundreds of documents, it's very powerful, this capability, okay? So this is really the basics of it. I want to mention that what you saw is the building blocks of RAG systems. And this is what's happening with most of the customer service agents, some good, some terrible. We've all experienced about chatbots. But behind the scenes, the basic technology is RAG, like retrieval-augmented generation. And really the important parts, the foundational parts are not really that hard. Having said that, I want to quickly end on some caution here for you. Agentic design, what you really saw was this part here. Agentic design is these building blocks of agentic systems, various technologies. We would really just scratch the surface, but you saw the main parts of it, right? But in order to make this into a production-grade deployment, there's a lot of other things that need to happen. Something called evaluations, which we will talk about in workshop 2. Guardrails, safety, security, monitoring, observability. These are elements we will talk about in workshop 3, okay? I just want to give you a preview of what is coming. And also in agentic design, we'll talk about truly agentic design patterns when you put together teams of agents to do pretty complex tasks. That's what we will cover in workshop 2 and then production considerations in workshop 3. All right, I want to quickly plug our Agentic AI program. So ReadyTensor actually offers an Agentic AI Developer Certification program. It's a free program. We have 15,000 people enrolled in it from around the world, 120 countries represented. It's free. It's a very comprehensive program. So it covers what we are showing here. The design, LLM workflows, it goes into agentic patterns, it goes into production considerations. So if anyone is interested, just do check it out and it's available to you. All right. Okay, I'm here if anyone has any quick questions. Otherwise, reach out to me afterwards. I'm available.
I see a couple questions in the chat. I saw came in first and mentioned, I'm currently at a national conference for AI. MCP was referenced as an alternative to RAG applications. I've left with the sentiment that they are more or less the same thing with minor differences. Can you quickly elaborate?
Yeah, MCP is actually, it can be used for many purposes, but really MCP is more like a tool. So agents, I mentioned, can be given access to various kinds of tools, okay? A tool, for example, could be go search the internet and find information on something, or send an email, right? It could be a tool to send an email based on some capability you're giving it. It could be many other things. Usually it's like external capabilities you're providing. And the beauty of MCP is it's basically like a common protocol the good folks at Anthropic have created for how agents can make use of external tools, okay? There are a couple of lessons on MCP within this Agentic AI certification program. And it also differentiates like how MCP, how it relates with tools that you use internally versus MCP. So there's a lot of hype as well. And there's some security concerns with MCP. There was a recent pretty big issue with GitHub's MCP tool, for example. You can just search for it. But still, it's a powerful technology. And the good thing is because of the common protocol, you could literally, there's at this point, like thousands of really good MCP tools available out there that you can provide to your agentic systems. So it's a deeper conversation. You can search for MCP, but there are a couple of lessons in the Agentic AI program. There was one other question, I believe.
Yes, I had posted a few. So she's asking, could we add knowledge in this repo? Is it ready to upload files?
Okay, I wish I hadn't done something I did 1 hour before, which is to remove a data folder. What we intended to do was to actually have documents in PDFs or Markdown, but just to keep the code simpler, we just literally put the dictionaries right in the notebooks. So definitely what you can do, if you want to do open a PR, do that, create a folder, add your documents. You can ignore the documents, but if you build the capability to read PDFs or Markdown and open a PR, we'll accept it, okay? You can use it. And by the way, you don't need to write your own reader. There's beautiful tools available for reading PDFs and CSVs and all kinds of documents you can have, right? So you don't need to build your own capability there, all right?
Okay. Can we create an agent specialized in a domain, or is it better to create a knowledge graph with embedding?
Knowledge graph with embeddings, okay. That's a complex question. It doesn't have to be either or, really. We talked about RAG, okay? And RAG has limitations too. I showed you some really good stuff and it works, but in a lot of real world production systems, there's a lot more that starts causing you problems, okay? So that's where knowledge graphs come into the picture, where the documents have some kind of relationships between them. And also the other issue with RAG is that each document has the same weight, right? What if you have two documents, one is an older one is a newer one that replaces the older one, but we never bothered to take it out, right? Maybe your PTO policy changed. In RAG, it has no idea which one is better or which one replaces the other. It gives equal weight. So that kind of time decay is not there in RAG. And there's other issues with RAG as well. So knowledge graphs really help you build semantic relationships between these vector embeddings, and it's helpful for that reason. You can do all kinds of more semantic search, more intelligent search. And so you have that. Now, specialized agents, I don't know exactly what you mean by that. It could mean a lot of things. It could mean fine-tuned LLMs, for example, instead of just using the RAG knowledge base as something you provide externally. You can actually train knowledge into the agent's weights, right? The LLM's weights. That's a whole other level of LLM complexity. We didn't get into that. LLM fine-tuning, there's a whole lot of science. If you really get into that's more theoretical. That's when you start getting away from applied LLMs and more theoretical parts of it. But you can also build some specialized ones. For example, these coding agents, they've been really trained on producing code, right? And they've been instructed to produce code, which is different. There's now agents being created, chatbots being created to produce medical assistance, right? Or legal assistance. And they are trained specifically on that domain knowledge. It's not RAG, it's actually trained into those LLMs. When you talk about specialized agents, we could be talking about providing that specialization through RAG, through fine-tuning, and knowledge graphs, and other kind of mechanisms to it. It's usually a combination of all of them. Mixture of experts is another technique, right? To put together different kinds of LLMs that have different capabilities. And if you get one type of problem, you pass on saying, you handle that, you handle this other part, you could do that. So it can get quite complex if you're really trying to build these commercial grade chatbots. All right, anything else?
Another question came in asking about your experience in embedding, if you can share more about that.
With embeddings, okay, there is a lot with embeddings, okay? First of all, when we talked about RAG, I didn't even get into some of the parameters around RAG. The embedding size, right? There's models of different sizes. When we do the embedding of documents, what is the size of the documents? How much overlap you want to have between the documents? A really long document gets broken up into chunks. The chunk size and the overlap between the chunks is another design parameter where you have to play around with it and see the results. Okay, this is where we get into evaluations and testing to see which tends to perform better. There is no one good universal answer. I can tell you that. It really depends on the problem and also the cost, right? If you use a really large embedding model, then it's going to cost you. It's a lot of memory you're consuming, right? I don't have a one good universal answer other than to say, play around with all the parameters, see how it impacts your performance. Actually, exercise 2, that part 2, at the bottom of it, there's a couple of exercises related to that.
The next question that we have is related to RAG-based systems. Or RAG-based systems just enriching my user prompt with information it retrieves from another system? If you have a giant corpus of information that doesn't fit into the context window, do you have to look into fine-tuning a foundation model?
Yeah, no. So fine-tuning is not necessarily because you're not fitting into the context. You're getting into really context engineering. This is a whole other area of science that has emerged recently. A year back, you might have heard the term prompt engineering, and that was about how to construct prompts effectively. And now a lot of experts are saying it's not really prompt engineering, it's context engineering. And context engineering is about that prompt, but a combination of the short-term memory, long-term memory, how you put the most effective information in as little space as possible. Every token costs you money. By the way, input tokens cost you money, output tokens cost you money. Tokens are basically, you can imagine them like words, just sub-tokens, sub-words that we're sending, right? All the prompts get broken into tokens and they cost you money. You might say, let's just get the biggest context window LLM, put as much information as possible, but first it costs you money and it actually starts degrading performance at some point. So it's really a science of how you put together the most useful information. How do you even find that useful information? You need to have effective RAG and then knowledge graphs and all of that. Fine-tuning, though, I would leave it a little bit on the side. Fine-tuning comes into the picture. If you're really building a chatbot that you're making available to other people on a commercial basis, you're building GitHub Copilot, right? Something like that, then you will want to fine-tune. Most of our applications can be solved with very clever context engineering, RAG, and other techniques like that, okay? So yeah, it is about enriching user prompt, but let me just tell you, it's a lot more science to that prompt engineering, and that's what we are calling context engineering these days.
I see another one is chunking of documents, analogous to the n-gram concept in classical NLP.
Yeah, I never thought of that, but yeah, it's just much longer. The N is much longer. The N can be like 500, the N can be 1000. But yeah, it's basically you take one big document, right, text, and you say the first 500 words, or I don't know what exactly is the optimal size for these models, but it could be like 500 characters or 500 words, one of those two. And then you don't like have like them exclusive, right? There's an overlap of the second chunk with the first chunk, and that's the second chunk. And the third chunk overlaps with the second chunk. A little bit of overlap, you have to define that. And then you take that chunk, you send it to the embedding model, it comes back with a vector representation, and you store it into the vector DB along with the original chunk of text, because you're going to need that later to send to the LLM. Okay.
Fantastic. I think we got them all. If we missed any, yeah, go ahead.
Yeah, just real quick, separation between docs. That's a useful point, because if you play around with some of these documents, you might find that you're going to get multiple documents as hits. And this is where I was saying that K factor becomes important. And you can get very clever about the K as well, because maybe quite often what you find is the same document and the overlapping chunks come back as hits. And that's not a bad thing by itself. But if you want some additional context to come out, you intentionally choose a little bit different retrieve document. But usually we are not really messing around that at that level. So it's not that bad, the situation, if you get 2-3 documents and there's not a lot of separation, because at the end of it, you're taking all of those retrieve documents, the top K, and you're giving it to the LLM. And if the LLM is smart, okay, it depends on how good that base foundation model is. The more expensive ones, if you use ChatGPT 5, it's a much different situation than some much smaller model. If you give it the right context, it will know that, oh, the first 2 documents that you gave me, the first 2 chunks are relevant. The third one is completely irrelevant. I don't care. And so it's just, you're saying, here's all possible information you might find relevant, and find the answer. If you don't find the answer, just say you don't know. Okay.
Wonderful. Thank you so much, Dr. Desai. We appreciate your expertise and for joining us here this evening. I'll go ahead and send out the recording and slide decks via email shortly. So thanks all for joining us tonight.
Thanks, everyone. Thank you.